See here I am discussing about third concept in this class. See, degrees of freedom. So already I discussed the concept generalized coordinates. So that means all coordinates not required to describe say the system. Just subtract constant number of constants from that. So remaining will be generalized coordinate, that is equal to degrees of freedom. So now I am discussing about degrees of freedom, DOF. Minimum number of variables required to describe a system. Describe a system. How many minimum number, not more, minimum number of variables required to describe a system. That is equal to F equal to 3n minus L. Here is number of particles. Each particle is having three coordinates. So 3 and 3n minus L is constants. So I am taking one example. See, I am taking one example. See, for example, this is a surface, a car, one object is moving like this. See, if you take one more, this is one pivot, otherwise it is moving like this. In this system, what we have, see here theta is there, this is pendulum, this is only moving in the x direction. So describe these two conditions. In these two conditions, we require only one variable is required to describe the system. That is equal to DOF for this system equal to 1. How many minimum number of variables required to describe a system? In these two systems, degrees of freedom is equal to only 1. How many variables are required? It is moving in the x direction. It is not moving in the it is not moving in the y direction. It is not moving in the y direction. It is not moving in the z direction. It is moving in the only x direction. Here also it is moving like this. What we have here only theta is theta. By theta only we can describe this system. Here only 1 degree, one coordinate. Here also required one coordinate. That is equal to degree of freedom equal to 1. That is minimum number means how many number of variables required to describe a system. If you take a particle, moving in xy plane, the particle is moving. So if we describe this system, we have to describe this system, the number of minimum variables means 2. X and y positions should be required to locate this particle. So the degrees of freedom here equal to 2 in this system. For example, if you take one more, see here, this is pivot. See here that it can move like this, it cannot move like this, it cannot move like this. How many constants are for this pivot? 2 constants. So by calculating constants, we can subtract 3n minus l. We can get the degrees of freedom of the pivot. For example, take one more example here. This example for required given for constants only, not degrees of freedom. So one more, a cylinder is moving like this. A cylinder is moving like this. See, this is smooth surface. First we look at x direction. This is y direction. This is z direction. See, now this is a cylinder. This is moving like this. For example, this is a cylinder. You go for the here. This is a cylinder means this is a marker. It is moving like this, like this, like this, like this. See here, the translation motion is there. This translation is there. Translation is there. Is it is moving in translation in y direction? It is not there. It is in z direction. It is there. Z direction also it is there. See next for we are moving to rotation. Rotational motion. It is there in the rotational motion? No. If it is there in the this direction, rotational, no. Here rotational is there, z direction also is there. So how many are here? It is moving like this. So 3 of 2 minus 2. See how many are here? Here these two are translation, rotation is there, translation is there, rotation not there. So finally the degrees of freedom 6 minus 2, that is equal to 4. So any cylinder it is moving on smooth surface, the degrees of freedom for that one 4. So what is there here? One is translation, then rotation, it is not there in the x direction. This is in the y direction, it is not there. Rotation it is not there. Rotation is there. So we don't have 2 or there. 2 or we don't have. That is equal to 2. Two constants we don't have. So 6 minus 2, that is equal to 4. Have you understand this one? Okay, we don't have here in the y direction, it is not there. Rotational motion, it is not there. Remaining are there. So 6 minus 2, that is equal to 4. So this is the degrees of freedom. So I am taking some more examples. If you take two particle system, say number of degrees of freedom equal to 3n minus L. Here 1, 2, 3 of 2 minus constant is 1. So 5. For 5 degrees of freedom for two particle system. Take one more third example here. This is 3 particle system. The degrees of freedom equal to 3n minus L. 3 of 3 minus 3 constraints, n minus 3, that is equal to 0. Degrees of freedom equal to 6. If you take one more example, I take one more example. Sorry. Degrees of rigid body rotating about fixed axis. About fixed axis.